Today we are going to learn Unit 7.6, which is our slope field. It's a pretty easy concept. Well, what is a slope field? Here's that big, huge thing. I never ask you guys to really understand all of, to memorize all this. I asked you to understand what it's saying. This is in your packet, but all this whole thing is saying is that we're going to look at each unit, each coordinate point basically, and determine what its slope is. And this lets us solve differential equations analytically without having to understand other things. So like if we have a question that we couldn't have solved algebraically or calculus-wise, like notation-wise, then we can use differential equation slopes, our slope fields, to figure it out. So we're going to begin with this, but before we begin, let's actually review some slope information. So very simply, very basically, the slope of y equals x is going to be that positive linear line. We're at the slope of positive 1. So slope of 1 gives me that perfectly diagonal line. Slope of 2 is actually going to narrow my line or make it more vertical. So there's my slope of 2. And then a slope of 3 is going to become even more narrow. What about the opposite side? What about y equals negative x? Well, that's going to be a slope of negative 1. And then a slope of negative 2, again, is just going to become more vertical. And a slope of negative 3, more vertical, and so on and so forth. The only other two lines that really matter to us would be when y equals 0, that's the x-axis, or when x equals 0, which is my y-axis. Those two are going to be very important to us as well as what a zero slope looks like, which is just that horizontal line. Okay, so problem number 1 we'll do together. So we're going to do this, and what they want us to do is create a slope field based off of what we know. So first things first, you want to look for where your slopes equal 0. That's going to be our number 1 kind of point today. So when does slope equal 0? Well, what value of x would make dy dx equal 0? Negative 1. You are correct. So dy dx equals 0 when x equals negative 1. So where is that on this graph? X equals negative 1. Is that not this vertical line right here? It absolutely is. So at x equals negative 1, we're going to go ahead and draw. I'm going to make it a little thicker. We're going to draw our slope field right there. We know our slope, dy dx, is equal to 0. So that means each point right here just looks like this. Okay? We'll continue on. Now that we figured that out, so the first thing you want to do is figure out where your slope is 0. The next thing I like to do is look at my x and y axis. In this instance, because I have x's, I'm going to look at my y-axis because that's where x equals 0. So the reason we look at the axes is because that's typically where x and y equals 0, and we can just kind of go from there. So when x equals 0, if I plug that in, then my y values are all going to be 1. So my slope is all going to be 1 right here, right? Dy dx is going to be 1. So that means I have a positive slope of 1. Nice little diagonal line throughout. And then from there, all we're going to do, that was the spot we were looking at, sorry. From there, all we're going to do is see what depends on my x or y, depending on what we're using, or both. So what that just means is plug and chug, as simple as that. So first thing we're going to look at is my x is equal to negative 3. Well, what happens when I plug that in? It becomes negative 2. So all of these slopes are going to be negative 2. So that's really easy for me to address. So negative 1 would be a nice diagonal line. Negative 2 is going to be slightly more narrow. And from there we just keep going. So we did negative 3, maybe we should do negative 2, which has a slope of negative 1. So again, that's going to be that nice, neat diagonal. Now we've got these done, so now we're going to move over to 1. And at 1, our slope is going to be 2. Again, I'm plugging it into my equation, so 1 plus 1 is just 2. So here we have a positive slope of 2. So it's not quite this angle, it's going to be a little less, a little more narrow. Okay, continue on for 2. So if I plug in 2, I should get a slope of 3. So again, a little more narrow. And finally, if you guessed it, yeah, even more narrow. I used a really thick pen so you could see it, but I can use a thinner pen as well. So if I want to double check, it's going to go through, we did that one. Okay, if I want to double check, I got it right here already ready. So this shows us all of my slope of zeros, and we can see from there all of my slopes, my slope increases and my slope decreases here, so they show that same pattern. Okay, well, what happens if my dy dx now equals y as my variable on the right side? Well, we're going to do the same thing. We're just going to go through. So where would it equal 0? That's the first thing I'm going to look for. Where would my slope equal 0? Okay, well, where does my slope equal 0? 1 minus 1 equals 0. So I'm going to assume that at y equals 1, that we have slopes of 0. Well, where's y equals 1? Is that this point right here? Not quite. That's x equals 1. Here would be y equals 1. So I'm going to go ahead and just plug in, make this a little bit smaller. I'm going to put my lines, my 0 slopes all throughout. Okay, so now we figured out where slope is 0. Then you want to look at when x equals 0 or when y equals 0. Well, in this instance, we're doing y. So when y equals 0, that means we're looking at the x-axis, right? This is where y equals 0. So if y equals 0, what happens? I plug in 0 and it becomes -1. So that means all along this point, I must have slopes of -1. So that's going to be that perfectly negative diagonal. Okay? And then from there, I just plug away. See what depends on it. So we're going to go ahead and start at the top. And so that's going to be y equals 3. So when y equals 3, my slope equals 2. So up there, we're going to put a +2. So slightly narrow, not quite diagonal, not quite perfect diagonal, I mean. Okay. Then we're going to look at y equals +2. And that gives me a slope of 1. So now I want a nice diagonal. Okay. We already got these two, so I can jump on down to y equals -1. And that gives me a slope of -2. So at this point, I'm going to do my slope of -2. Here was -1, so -2 is just going to be a little bit more angled. Okay, continue on, and we get, we're looking at y equals -2, so my slope is going to be -3. We're going to do it right here, so continuing on, we're just going to make this even more narrow. And you guessed it, down here, what do you think is going to happen? Yes, even more narrow, almost a straight line. Awesome. If I want to double check my work, there we have it. There's my 0 point. Then we addressed our y-axis first, and then from there we just kind of extrapolated each point. Okay? This next problem you can do on your own. It should be pretty easy. You should be able to do this next problem on your own as well. Again, it should be pretty easy. But what happens when I have both variables? Again, I could mentally rewrite this and just see it as the formula we know, y equals -x. But let's go ahead and do what we know to do. So the first things first, let's figure out where our zeros would be, right? So what values would give me 0? Well, would my origin give me 0? That's a pretty good place to start. X equals 0, y equals 0, right? 0, 0. So I know that I have a slope of 0 right here. Well, guess what? We also have slopes of 0 elsewhere. What value of x would I need to have and y for them to cancel out? Well, they need to be the same value but opposite signs, right? Well, what about here? Is that -1, 1? Yeah. What about here? -2, 2? Yes. -3, 3? Yes. What about here? This is +1, -1. Guess what? Still 0. +2, -2. +3, -3. And I've got my 0 slopes determined. Okay, so that was step 1. Step 2, then we figure out, okay, well, what happens when x equals 0 or y equals 0? So let's start with x. When x equals 0 would be all these values right here. But we can't just determine it like before. We can't look at an entire line. When we have x and y, we actually have to look at each individual coordinate point by itself. So let's start with our positives, it's a little easier here. So if x is 0, the only value is going to be my y value, right? Y is 1 right here. So this has a positive 1, positive 2, so a little bit more, positive 3, a little bit more. What about down here? If x is still 0, then it's just negative 1, negative 2, and negative 3. Okay, so we dealt with our x is equal to 0. What about dealing with our y is equal to 0? That would be my x-axis. So my y's are all 0 here. So if y is 0, x is positive 1. So this is going to be positive 1, positive 2, positive 3, negative 1, negative 2, negative 3. And then from there, you just do each point as you see it. So let's do our quadrant 1. This is going to be positive 1, so 1 plus 1 is 2. And then this is positive 2, positive 1, so 3. This is 3 and 1, so 4. This is 1 and 2, so 3. 2 and 2, so 4 and 5. 1 and 3, 4. Ooh, that's not really 4, it's more like 3. And 5 and 6. And then you can continue on and so forth, and you would just do each value. So coordinate point, this is 2 comma negative 1, so 2 plus negative 1 is just going to be 1, so we're going to keep going, etc., etc. You can kind of figure it out from there, figure out the rest of this on your own. If I do want to double check, of course, I've got that double check right here for you. And one really cool thing to kind of note here is that along this line, where my slopes were 0, kind of drew it crappy, but what line did I just create? Is that the linear line y equals negative x? Yes, it is. So we can extrapolate what this slope field was. We can figure out its equation based off of the actual slope field. Okay. Here's another yx, so again, same thing. First thing you want to do is figure out where it would just be 0, what happens when x is 0, what happens when y is 0. So the only thing I would really note here is when x is 0, all along my y-axis, when x is 0, what happens? It's a 0 in the denominator, which means it's an indeterminate form. And so that means that at 0, nothing should be happening on this y-axis when x equals 0. Nothing should be happening. I should have no slope lines. And let's just double check to see if that happened. And it did. Look, there's nothing going on. Here I got some lines, but over here I don't. Okay, same with this one. Again, you got that multiplication, so you would just kind of figure it out. Where does slope equal 0? What happens when x equals 0? What happens when y equals 0? And then each individual coordinate point. Okay, again, here's another one. For this one, y is my denominator. So when y equals 0 or the x-axis, I shouldn't be touching it. It's indeterminate. There we go. All right, so let's actually move forward. Let's use some slope analysis to do some matching. So we're on our matching exam. I think it's labeled as example 8 for you guys. So we're doing 1, 2, 3, 4, and here they are, and we're just matching them up. Well, how do I figure it out? Man, I got 4 different slope fields, and they look kind of funky. The first thing I would tell you when you're doing matching games like this is, where are my slopes equaling 0? That's going to be the first one. For example, right here, I can look for zeros. Where it should be 0 is anytime y equals 0. But there's also another clue over here. So not only will I know when y equals 0, my slope should be 0, but I should also know when x equals 0, nothing should be happening because it's in the denominator. So whatever graph matches this, when all along the x-axis, I should have slopes of 0, and all along the y-axis, I should have nothing. So if I find a graph that matches that, I did my job. Okay, same with over here. All along the y-axis, because x equals 0 now, my slope should be 0, and all along the x-axis, I should have nothing. This is my clue. Okay, what about up here? Well, now they're multiplied to each other, so that's pretty easy, right? When x is 0, slope has to be 0. When y is 0, slope has to be 0. So either axes should have my slope equaling 0. So we should have the horizontal lines on both axes. And then finally here, this is x minus y, which if I mentally rewrite is the same as saying y equals positive x, right? Negative y equals negative x, y equals positive x. Okay, so then this should be similar to my linear line, so that means all along my y equals x line, I should have slopes, right? Anytime x and y, or anytime y is the same value as x, right? If x is 2 and y is 2, x is negative 1, y is negative 1, etc., etc. I should get my zeros. So let's just double check if we understood that correctly. So here, again, I should have a linear line going through with slopes of 0. And boom, there we go. I see my linear line coming through. Those slopes are getting closer and closer to a horizontal line, which is a slope of 0. So that means they are approaching 0. What about over here? We said that anytime x equals 0 and anytime y equals 0, we should have a slope of 0. So here you can see slopes of 0 all across and slopes of 0 all across my axes, so that's correct. Over here we said that my x-axis, because y is on bottom, my x-axis should not be approached. But my y-axis should have zeros, so zeros along the y-axis. I am not approaching. You can see none of these values are close to becoming horizontal, whereas these values are all close to becoming horizontal. And then finally here, my y-axis, because x is on bottom, my y-axis should be unapproachable, but my x-axis should all be 0. So here you see all my x-axis, all zeros, all my y-axis, unapproachable. Okay, I already had this, I forgot to animate this, so I'm sorry, so the answers are here, but again, the same thing. Sine x, so this looks like a sine curve, but if I wanted to double check, if I look for my zeros, when x equals 0, sine of 0 is 0, so all along my y-axis should be slope of 0. Here, 2 minus y, so where would make my 0? 2 minus 2 equals 0, so y equals 2, I should have a slope of 0. Okay, over here, this just equals x. So this is similar to whatever x value has to be my slope. So if x equals 0, all of these slopes should be 0. All of these should be 1, negative 1, positive 2, 3, 4, 5. It should be negative 1, negative 2, negative 3, negative 4, negative 5. And that's correct. Here, similar thing is happening. It's a pretty standard linear equation right there, 0.5x minus 1. But now I just got to figure out where is it going to equal 0? Well, I have to make this equal 1. So 0.5x equals 1. So x must equal 2, right? 2 times 1/2 equals 1. So look at this. X equals 2. It's all zeros. Okay, our next page. So here, 0.5y. Now we're looking at our y. So what value of y would get me 0? 0, of course. So here's my x-axis. They're all zeros. And from there, they just extrapolated out. Number 6. This is where we have both variables, so negative x over y. So again, over y, that means when y equals 0, I can't approach. So that's our x-axis. So we look at our x-axis and you see nothing is approaching it. None of my lines are even close to being horizontal. But when x equals 0 on the y-axis, these should all be zeros. And look at that, it's correct. And then finally we have y equals x plus y. So again, this is because I have both variables, I can mentally rewrite this. It's the same as saying y equals negative x. Well look, y equals negative x. Do you see a line right there? Because I do. At every value where you have the same number but the opposite signs, you're going to have that 0 slope. So 0, 0, yes, but negative 1, 1, negative 2, 2, or 1, negative 1, etc., etc. You're going to have those 0 values. To double check those, there were the answers 1C, 2A, 3B, 4E, etc., etc. You can kind of see those. Again, the point of this is not to like, oh, I got the correct answers. The point is to understand. Here's another one. These are true, like they're truly similar to AP problems. So these are really good questions. If you understand these 3 questions, then you got slope fields and we're good to go. If you struggled on these 3 questions, this is more like what an AP format question would look like. So you may need to see me about this. So what slope field does this represent? Well, one way to do this would be say, okay, well, let's look at every single one of these and just kind of figure out what that basic slope field will be. Well, that's a lot of work, right? What about just figuring out its 0 values, okay? So let's figure out where are these lines trying to become horizontal? Well, they are trying to become horizontal right here and right here, right? That's where we see them trying to become horizontal. And what does that kind of parent function look like when it looks like this? That's an absolute value function. So we do have absolute values everywhere, but we just got to figure out, okay, where does this absolute value exist? So that's, again, you just start plugging in values to kind of see. I would pick a value where you don't have a chance of maybe having the same answer somewhere else. Like your zeros and your ones might have a repeat answer in here, but somewhere further out here, probably not. Like, let's see. 4. So -4, we'll do -4 comma 4 and we can, or sorry, -4 comma 5. And this looks like it is a negative slope very close to like a high number, 5 or 6 or something. So we're looking for a negative high number slope because it's almost vertical. So you plug that in, we were doing what, -4 comma 5, some value right here. Right here. That's what we're looking at, okay? So then you plug those in. Here's my x, here's my y, and I plug it in. So 5 minus the absolute value of x, so 5 minus 4 gives me a positive 1. And from there, you just kind of keep going, and ooh, something funky happened. Ah, I see. I suppose it would help if I wrote my coordinate point down correctly. This is -4 comma -5. My apologies. So when I plug that in, -5 minus the absolute value of -4. So -5 minus +4 gives me -9. So that seems about appropriate. Okay, let's look at B. What would be the absolute value? So here, so 5 minus my true value -4, so +4 gives me a +9. So it can't be B. We know that. It absolutely can't be B because this is a negative slope. And then our next one becomes the absolute value of them, so -5 minus -4, so +4, absolute value is still going to be +9, so this one's incorrect. And then I test it here, y plus x, so -5 plus -4 on the inside gives me -9, absolute value is still a positive number. Probably not. We probably could have figured these two out immediately. If it's going to be an absolute value number, then none of these could have been correct. And then here, the absolute value of, so 5 minus the absolute value of 4 equals a +1. Well, this is certainly not a +1 slope. We should be able to recognize this. So this tells me immediately that B, C, D, and E are all incorrect. I don't even have to double check any of them. So we know the answer has to be A. But what happens if I didn't? Let's say I could only erase C and D and B and E all had similar answers. Well, then again, you pick another point, some random point out here in the middle of nowhere, and you figure it out. Does it look familiar? Okay, so let's double check that answer, and there it is. A is the correct answer. Yay! Okay, here's another one, but this one's a little bit different. This one says that this is the slope field, yes, but these are not going to be the answer for the equation. These are going to be the answer for the integral of whatever the slope field is. So basically, a couple different ways we could do this. First of all, it's good to try and identify what this slope field is. Second of all, it's also good to figure out, okay, so these are all integrals, so the derivative of this should equal that slope field, right? Okay, so the derivative of my first value is just going to be cosine. This one's going to be negative sine. This one's going to be negative cosine. And this one's going to be positive sine. Okay, we can kind of figure out this last one, but this one's going to be, what, 1/2 times sine x squared times, so we derive that, and that actually becomes, my 2 comes down, so that becomes sine of x times the derivative of sine, so times cosine x. So the derivative down here is sine x cosine x, and from there we can just extrapolate. So then we would just figure out in red which of these match. Well, this one probably not, so we can kind of look at these and figure it out. From there, just doing the same thing we did last time, but we get the same answer. We know that that's actually going to be the graph of cosine, and that kind of tells us right here at my 1 and my -1. Oops, I went too far. It tells us there at my 1, or sorry, this value, pi, and my negative pi. Why did I say 1? We're in sine and cosine. Okay, and our final one is another which of these matches this. So again, I tell you, you just kind of pick values and you plug away. Simple as that. But I'm going to go ahead and give you that answer. It is the bottom one. But again, it's not about getting the correct answers. I gave them to you in this video. It's about, did I understand how to do these 3 questions? Okay, that's the finale for 7.7. We'll pick up on 7.8 with differential equations.